These are the 19th century Leetonia Beehive coking ovens. I'm Darren, and this is the Industrial Revolution. So coking ovens are used to make coke. Coke is used to make steel, among other things. Before we go into any more details about this, I want to get something very clear. These are not structurally sound. If you come visit, do not enter these. It may look like I'm entering them, but I have two things you may not. First, I have a camera that works with remote control. And second, I have a 10-foot long selfie stick. I can poke this almost all the way to the back of these coking ovens.
As soon as you pull into the parking lot, you can't help but see these ovens. Set into the hillside, faced with brick and stone, the entrances to these ovens look widely spaced, but the ovens themselves are actually built right up against each other to maximize the heating effects. Obviously, many of these have partially or even entirely collapsed over the years, which is why they do warn against climbing into or on top of the ovens. Just look at how the intense heat has transformed those bricks around the bottom where the coke was formed. The ones in the parking lot are nice, but to see the good ones, you've got to walk just a bit further into the park. They built a battery of coke ovens on each side of this so-called canal down the center. The canal was rock-lined with a rail line down the center to transport the finished coke from the site. Each row of coke ovens, which is called a battery, contain dozens of separate ovens. The first set is pretty overgrown, but if you walk just a bit further to the next set, you can get a much better look at how they're built.
So the site itself here started out with about 100 coke ovens, and they ended up with more than 200 in the end. But before we get to that, let's start with how one of these actually works.
Each oven is buried fully into the hillside, as you can see. These were built right next to each other to minimize the heat loss. You start off by laying 2,600 foundry bricks in a circle 12 feet in diameter. From there, you use 4,200 more bricks to build a dome about 7 feet high. This is mortared together with a mix called loam, which is made of dirt and water, which is then packed in and will bake hard under the intense heat of the oven. At the top, you leave what's called a key ring. This opening, 14 inches in diameter, acts as a chimney for the oven. Once the dome is completed, you then build up the front wall of brick and stone and fill the top with dirt for insulation. The dirt between them was heated up nearly as hot as the ovens.
So how do you actually make coke anyway? Well, it's just coal, and you load it up in this hopper. This is the Cherry Valley Iron Works. You load the coal into here, run it across the top of the Beehive ovens, and you line up this chute to the one that you want to charge. Remember, there's a hole in the top of the Beehive ovens. You open the chute and you drop anywhere 5 to 10 tons, depending on exactly what you're going for, into the Beehive oven. Now, that's not a lot, that's maybe 2 or 3 feet high. You then shove this away to the next oven, and if it's already been used, if it had just been used, there's so much heat in that oven, the coal would probably spontaneously combust anyway. You wouldn't have to do anything to light it. If they were cold, like when you're first starting out a set of ovens, you'd have to stick wood in there to get the coal going, then the coal would get going. But in any case, once you get the coal burning really well, and it's nice and hot, then you brick up the entrance. You close it off and cut off almost all the oxygen, and you ignore it. You ignore it for anywhere from 48 to 72 hours, and just let it burn. Now, once the oven has stopped off gassing, you stop getting the massive flame shooting out the top of it. At that point, you have coke inside. Your coke is extremely hot. You have also pretty much exhausted any oxygen you had inside, and it's time for you to act. So you reopen this entrance that you'd bricked up earlier, and you rake out this glowing hot coke. Now, it's immediately exposed to oxygen. You have to act fast. You quench it in water very, very quickly. If you don't quench it in water, it's all going to turn to ash. Remember, this is almost pure carbon at this point, and it's extremely hot. So you quench this in water, and now you have the coke sitting here ready to ship out, ready to use, whatever, and that's where these carts came up. This one's not in quite as good of shape as you may have noticed, but from the ledge, you pull the coke over and shovel it into carts like this. They were down in those trenches, and then that gets shipped out and used.
Obviously, all this heat was hard on the bricks. So you can see the faces of these ovens have an assortment of different bricks as they were built and repaired and rebuilt over and over for the life of these ovens. The hook, I think, was used to secure the door when firing. This one has a couple layers of brick on the face instead of just one, like some of the others. Some more hooks. They seem to have survived in this area more than the others, probably due to the multiple layers of brick on the faces. Check out the different style of arches. Some of these are just a single layer of bricks. Some are 2 layers. And some even have up to 5. Depends on who rebuilt it last and when. Here's one oven where they even used a stone arch instead of brick. The platform we're walking on during construction had a light rail line to move materials. That was removed once construction was finished. In operation, hot coal was raked out onto this platform, quenched with water to cool down, then shoveled into the rail cars located in the ditch or canal to our right. Above us, of course, was the rail line with the coal cars that was used to charge the coke ovens from above. Across from us, there's another set of ovens just like this one. So why the mix of stone and brick? Well, as near as I can tell, the brick was used right near the openings to the ovens, only in the area that would take the most heat. It's not as strong, but it's a lot cheaper and easier to replace when the heat inevitably destroys it. The stone, which was more expensive and a little harder to work with, was used in places a little bit farther away from the entrances. These are places that are not going to take quite so much heat, so it should last longer. The town Leetonia got its name from the Leetonia Iron and Coal Company, which was first formed here. The area, though, actually got its name, Cherry Valley, from the fact that when these coke ovens were in operation, the hills themselves would glow a bright cherry red from the heat. Initially, with 100 coke ovens, they produced 250 tons of high-quality coke per day at up to 95% carbon. In 1900, their production peaked at 70,000 tons of high-quality coke, coming from 200 ovens.
So it's originally located here because Leetonia had both iron and coal. And that made it the perfect place to build these coking ovens and the blast furnaces, which were here. Unfortunately, by the late 1870s, the coal mines had shut down. They mined through the stuff that was easy, and the rest of it wasn't worth doing, but they kept importing the coal for a while. They were able to get less expensive coal. The iron kind of ran out here, so they had to import that. And eventually, by 1930s, they just gave up completely, and they closed down the site, and they abandoned it here. So though the Leetonia Beehive Coke Ovens did shut down nearly 100 years ago, while they were operating, they were a major contributor to the steel industry. You had over 200 coke ovens on site. You had several blast furnaces on site. So they were producing iron here. They were producing coke for other blast furnaces. Today, you can come explore this and see how this worked and explore through the blast furnaces. Just please don't go into them. And as you explore, you'll see why this is the Industrial Revolution. Hey, wait a second before you go. I really need your help. I love coming out here and filming on location and bringing you all of this great stuff, but it is expensive. So I need you to help me grow the channel, and the easiest way to do that is just hit like. You know, it's easy, it's quick, costs nothing. Hit like on the video if you haven't already. If you can subscribe and hit notify, YouTube will let you know when I have new stuff coming out. Also share the video with your friends, share it on social media. Let's spread the word. Also, if possible, if you can help me out financially, that would be great. It is not cheap coming out here and making these, aside from the fact that I'm spending many hours researching and editing videos. I do have travel costs that I need to cover. So best ways to do that, you can help out on Patreon. It's patreon.com/Industrial Revolution. Or just hit the super thanks button on YouTube, that works too. Finally, something I've just set up recently, I do have an affiliate store. Right now it's just through Amazon. If you hit the shop link on either the end screen, which is probably up on the screen right now, or on the video description or the channel description, they'll take you over to my webpage. I do have some live steam engines there, some hand grain grinding equipment there. But if you follow that link over to Amazon, for example, anything you put in your cart, even if you don't buy the thing on the link, the channel will get a percentage of the entire cart purchase. And that's really going to help me a lot. It's going to help me keep making these videos, keep bringing them to you. So thanks again, and I look forward to seeing you next week.